Now let's look into the one example from recursive feature elimination algorithm, which is wrapper type feature selection. So we'll look into a step-by-step procedure for using RFE for feature selection in text classification task. So let's begin with load and prepare the data. Load the text data into a suitable data structure. Here obviously we'll take up a data frame, or you can use a text corpus also. Then let's prepare the data. So this is very important step, data pre-processing. So perform necessary pre-processing steps such as tokenization, removal of stop words, stemming or lemmatization, and handling special characters or punctuations. Okay, so let's do some of the steps till that extent. So what do we call this? Recursive feature elimination, RFE. Okay, we call this as a recursive feature elimination. Now, so required libraries has been imported. Import pandas as PD for us for our data frame. Then we have from SQL Learn library feature extraction and text import TF-ID vectorizer module. And sklearn feature selection will be calling up RFE and linear model, a logistic regression for the classification task. So our logistic regression is for the classification task, RFE for the feature selection, and TF-ID, TF-IDF vectorizer is for feature extraction. Then let's load and prepare the data. So we will uh, load and load the data as with a reference name data. So an X is data. Out of that, the text will be labeled as X, and labels will be labeled as Y. And let me call up and let me show you what is X and what is Y. Let me execute this once. And data. So this is what is our data set. Okay. Our data set consists of two columns. So one is text column, second one is label column. Out of that, the text has been labeled as our feature that you can see, and uh, label column itself has been labeled as Y. Simply to put it simple, this is your target variable, which is positive, negative, and this is your features. I love this movie. The food was delicious. The service was terrible. This book is amazing. I had a bad experience. This movie was disappointing. All those things. So after the data data pre-processing, let's have a quick uh, definition of the problem and object state objective. So clearly, let's define the problem such as sentiment analysis or topic classification. Here is the sentiment analysis. Then let's set the objective as identifying the most informative words or engrams for accurate classification. The main objective here is identifying the most informative words or engrams for accurate classification. Then we have prepared the data for modeling. Uh, so represent the text data as numerical features using techniques such as bag of words or TF-IDF or word embeddings. This is very important step when you deal with textual data. So it's so how do we handle this? This step is very important. Prepare the data for modeling, or to put to put it to put it simple way, represent the data, text data, represent the text data as numerical features using techniques such as bag of words, TF-IDF, or word embeddings. Okay, then split the data set into training and testing sets. So that's what we'll be doing. Let's get back to our notebook. So once load and prepare the data is done, now it's time to vectorize the text data. So that's why we have called up imported TF-IDF vectorizer. So now we will be creating an instance TF-IDF vectorizer class object instance, or you can simply say TF-IDF vectorizer instance. Okay, then after that, whatever the features that we think that we will be the text data we will be giving into the will be fitting into the TF-IDF vectorizer object using fit transform method. So fundamentally what we are doing there is convert the text data into TF-IDF vectors. TF-IDF vectors. Now, if you want to see, that's okay. I'm going to show you. So anyway, you know how text data looks here. Now let's call up the X underscore TF-IDF, and this is how it's a sparse matrix of type, and which consists of 41 stored elements in compressed sparse row. Now let's print it. Now you got to see what is that object. Now let's print it and see, and this is how it looks. So it's basically it has been converted text data into TF-IDF vectors, and what you see is TF-IDF vectors, and this features column, text column, has been converted into these many vectors, and you can see the vectors. So that's why we call it as a text conversion into TF-IDF vectors, and this is very important step, because the text data, representing the text data as numerical features using techniques such as bag of words or TF-IDF or word embeddings is very important. Until if it is not, the system can't understand. So that's the reason this conversion is important. So normally we prefer to go with TF-IDF vectorizer method. Then let's initialize the machine learning model. So let's choose a suitable machine learning model for text classification, such as Navy Base Support Vector Machines, Random Forests. Then initialize the model with default hyperparameters, or tune them based on the cross validation if necessary. So let's initialize machine learning model. So the model, initializing the model here. So we want to go with logistic regression because we want to do the classification. So let's create a logistic regression class object, or let's instantiate logistic regression class object, and that's what we did here. So model is equal to logistic regression. Okay, Then once that's done, let's move ahead. Then let's apply a recursive feature elimination algorithm or technique to select the features. So let's import the RFE module from the appropriate library. Basically, it's from scikit-learn. Then instantiate an RFE object. This is very important step. We instantiated a TF-IDF vector object. We have instantiated logistic regression vector object. Now we are also going to instantiate the RFE object. So let's instantiate the RFE object providing the initialized machine learning model as the estimator and the desired number of features to select. So two things we will be providing. One is uh, your initialized machine learning model, that will be the estimator and the desired number of features to select. Then once that is done, let's fit the RFE object to the training data and target variable to perform the feature selection. So the next step is initialize the RFE object or RFE selector. So RFE object has been initialized, instantiated. Now inside that, two arguments has to be given. One is estimator, which is nothing but our model object. You see that our model object here is logistic regression model object. Logistic regression model object has been given for given as the first argument. Then because that it's going to take that as a reference, and on top of that it's going to keep on building it and keep on doing iterative process, and it will bring up the best mm, best features for us. Then number of features to select. I'm going to select 5 features, and let's execute and execute and see. So set the number of features to select. Okay, that's what we did it. Okay. So now to perform recursive feature elimination, it's pretty simple as we do it with other algorithms. So here also what we have to do is we have to use you have to call up the fit method from the RFE object, and you have to give the two arguments. One is x train and y train. So then let's move ahead. The important aspect has to be done. Now it's time to execute and analyze the results. So retrieve the selected features using the support underscore attribute of the fitted RFE object, and assess the ranking of features using the ranking underscore attribute, and extract the most informative words or n-grams based on the rankings, and that's what we will be looking into. Okay, so that's it. Now let's execute it, and to see the selected features I have to call up the vectorizer is our object, tfidf vectorizer object, and from that object get features names out, and I have to use RFE because that has a feature. So RFE dot support, and this is gonna give me the features. Okay, selected features. So that's what I did. Selected features. Let me execute it, and you can see your selected features are buying, disappointing, had, regret, terrible. So these are the selected features for uh, respective classes. Okay. So now let's move ahead. Let's evaluate and validate the model. So train a new text classification model using only the selected features. evaluate the performance of the model using appropriate metrics such as accuracy, precision, recall, or F1 score. So, validate the model using the test set to ensure its generalizability. So now the next step is to evaluate and the validate the model. So x underscore selected x underscore tf idf. So this is what we got here. So here is that x underscore tf idf. Then with that rfe dot support, and so I'm taking both, and I'm just evaluating and the validating. So with respect to the respective metrics, and the final one is to print the selected features. It's pretty straightforward. Printing the selected features is pretty straightforward. Okay, so now let me execute, and let's interpret the results. So interpret the selected words or engrams in the context of text classification. So analyze the importance and impact of these features on the classification task. Okay, so that's how it works. RFE. So let's get back. So to put it simple, this code, so whatever we have seen, so remember always remember to pre-process the text data, tune hyperparameters, and perform further analysis as needed based on your specific data set and objectives. So whatever I have done is kind of a ready-made data set without much of pre-processing, but you require to do, because here the agenda, and then the aim is to learn and how to apply RFE algorithm, not how to do pre-processing. When the time comes for how to do pre-processing, we will be doing those projects also. Soon we will be starting mega projects where one project itself will take 4 hours, 5 hours, because we will be doing each and every step of our 10 steps in supervised machine learning process. So there we will be doing in detail, but for now we will just understand how exactly our feature selection algorithms work. So that's what is our main point of a target.